Hello, good morning, afternoon, my friends. Hello, engineers. Yeah, everything is running. Okay, let's continue with the DDR3L routing experience. Yeah. I think I have to reconsider, not inevitably to change, but to reconsider the placement or the rotation, the angular position of the DDR3 memory, because no. Yeah, I posted about the stream from the last week on LinkedIn with some pictures of the angular position of the memory module. This was marked as the, let's say, best, or I don't know, the least the least bad, or I don't know. So yeah, I thought about that because when the red and the green airlines are to be connected on top, it means that I have to go in between the pads or like around the module and use the gap in between these rows. And I'm not sure. The premise, the default premise of this part of the job is that, as you know, I don't know what I'm doing, and that's why it's so interesting to me, because it's something I can learn from the process. So I will keep this position, and we will see. As we checked last time and during my post, it seems that this is the best one. Okay, so last week I concluded the session in the state that all the green and red signals, or nets, better said, are fed out from the BGA of the MPU module. And now, according to this list I prepared in advance to the previous session, check if the rotation, that was the one I added. Fan out first, then route. That's what we have done. You establish a target net based, a target net based on the most difficult to route path. So, in my opinion, now the distance or length of all the green and red airlines are plus minus the same. The fact is that for the red lines, the path will be a little bit shorter because we have to target these, let's say, 24 pads. The situation is theoretically the same for the green ones, because we have to target the 24 pads below the first ones. But as I said at the beginning of this stream, there are two options. If possible, we can go in between the pads or around the module. And this will significantly prolong the path of all the green signals going to this group of pads. Significantly. There are not many airlines, 5 airlines are going to this section, and I believe in this section one of the nets from this coming to this section is the most difficult to route path. So there are two options. We can go around and in between, or we can go through. I always want to check what's possible and what's standard. So yeah, you can see it as a procrastination, but I want to check the Gerbers of the module of the reference design with DDR4. So let's say all these Gerbers, and then because it's DDR4, which is, as we find out last time, yeah, it's pretty elegant. It's pretty elegant, and it really seems that the MPU was designed for the DDR4. Okay, not interesting. Not interesting because it uses DDR4. I want to check the design with the DDR3, DDR4, not this one, maybe this one. DDR4, no. So which one? No, I thought that one of the reference designs I downloaded used DDR3. Probably not. Okay, that's the reference design I received from one of you. Okay, so it means that I'm going to stop F-word ink around and go to route this, because there is no help, there is no miracle. Okay, so they went in between pads, they went from both sides, they didn't have to go around the module, so that was their advantage. And yeah. I will. There is always a question. Yeah. One of these. I'm sorry. I really don't want to procrastinate. But yeah, based on my experience, I've gained in the last, I don't know, 10 years, or maybe 15. It's always better to start with the, as they mentioned, the most difficult path to route. But if you need to route the most difficult to route path, you need to know your constraints. And the constraints are, of course, all the vias for the other things, all the tracks for the other things, because you can't prioritize one factor of the design and to omit all the others. So I wanted to say that to be able to route the tracks, I would need to fan out the BGA package of the TDR module as well. At least the ground nets. Why? Because these connections will significantly limit the possibility to go in between paths. I think that's for sure. And we know that all the blue signals, the blue nets, as in the document, the application note of the DDR memory routing for the MPU module say that the blue signals are to be connected on the inner two layer. It means that all these signals must have vias near the pads, ideally near the pads. So it really means that all the gaps, all the valleys, all the streets in between pads will be most likely occupied by the vias. So it means that after I finish the fanning out of all the signals, we will really need to go like here and here in between. Okay, let's stop talking and let's start working. So as last time, we discussed that this quadrant to be fanned out, that the vias are facing this corner, then this corner, etc. You will know. So I will start with all the basically all the grounds, and then because the power really will be connected on the bottom side, then all the powers, and then all the blues. The blues, the blue airlines will be a little bit will be routed with the most narrow tracks, but the ground I will choose 0.2. And as we say, this is probably the optimal. Yeah, I verified last time that all the vias will be plugged, which is the standard technology of the 6-layer port as we are going to use. So I think this position is correct. Yeah, I will go like row after row, and then I will continue with another section. So if you want to comment it, or yeah, I forget to mention that probably majority of you are watching this stream from the recording of this from this stream, so you are not online. So thank you for watching. I really appreciate your time, even though I know that the stream is usually more than 1.5 hours long, but feel free to fast forward the stream. For instance, this job can be fast forward because it's nothing really interesting, I guess. Oh yeah, where is the half of the package? Here. It's 777, yes. So here is the half. Here is the, like here. I will remove the line after that. Okay. So in the meantime, if you can, I don't mean right now, but for instance, you on YouTube, you can, okay, yeah, see, too much talking. You can tell me what mouse are you using or what interface, user interface, not user interface, how to say the, yeah, I'm using the Magic Trackpad by Apple, but recently I have to change my the height of the chair because I realized I too much bending forward and I too much yeah, like pushing my elbow forward. As the result, I started feeling my wrist after long sessions of routing. Yeah, it's natural when you for like 4 or 6 hours only moving your fingers and not much your wrist, it causes problems, and I don't want this kind of problems. So I'm interested, what are you using? Are you using the standard mouse, the vertical mouses or mice, or are you changing them regularly, like every other week or every other month or every other day? How do you approach the, let's say, health safety aspect of our job? Because frankly, we all know that sometimes it's far from healthy to just sit and stare at the monitor, no blinking, no moving, backbone stiff. Yeah, you name it. We all know it. Yeah, it can be. Yeah, because of the grid, sometimes the position of the via is you know what? Yeah, we need it. I will keep this vias anyway. What was my idea? My idea was that these components can easily be placed on top. So it means the DDR connections can't be done inevitably, or not can't, have to be done with vias because we can go straight on the top. But I will keep it just to see, just to, let's say, claim the space, the area for this connection, because yeah, at the end, if not via, there must be a track. For instance, here. Yeah, we have some comments. Let's check them. Hi, David. Yeah, definitely. I've been using trackpad for, I don't know, yeah, not 10 years. I have the external one, yeah, as you know. I have to hide your comment. Yeah, this one, like the external one. Yeah, where are you? Here. Because my MacBook is now like the lid is down, is closed. But yeah, before I purchased this external trackpad, I used the internal one. But the external is much better because, yeah, it's not in the middle of the keyboard, so you can rotate it, you can move it around. Yeah, definitely. But these caps definitely wouldn't affect the routing much because I will go not around them, but just in between the pads. And I want to say that right now I just need to know where will be the connection. And of course, some of these caps, because as we discussed, the tracks will go from upward in between the, like in this section, in this gap, and the green ones from this entry. So even these ones can be on top, some of them. But at least now, the ground vias will be definitely here, and the power vias, for instance, here, will be here as well, because I can't go with the track in between here. I don't want to find it like this, because yeah. Anyway, I will continue. Yeah, there is a thing. The plug via is a good thing because there is no hole, so it's safe for the solder, and it's safe for many things. But the manufacturer doesn't say that the plugged vias are ready to be plated, and I mean they officially don't support vias in pads. So vias in pads, in my opinion, in my experience, is something different from plugged vias placed in pads. And I don't want to use vias in pads, because vias in pads are really a different technology. At least, yeah, I'm not an expert in PCB manufacturing, but if you imagine pad with the via inside, the via is filled with some epoxy, but the pad is exposed, but the pad is not covered with the solder paste. So it's question if the epoxy filling of the via can protect the solder from sucking down from the wick. I don't know how the unfriendly process of the solder paste wicking or sucking down is called. So via in pad is something different than the plugged via. So yeah, I don't want to use it. I don't really know. We can check it. Let me...
Okay, thank you. Thank you. I don't know. It always happens when I get unmuted. Thank you, Francois, Jean-Francois. I don't know. Thank you. I don't know for how long I was on mute. I disabled all the hotkeys in the StreamYard to mute myself, but I don't know. Maybe my phone. No. Anyway. I think here is the answer in the here. No, here. Where it was. Here. Yeah. Copperfield, Vias. But this in the section of epoxy fill, I don't know. Let's wait. Let's wait. Okay. You can see here that I forgot to fan out the blue signals, the blue nets. Yeah, it seems, but probably I was on mute when I was checking that. If you choose the Copperfield, where is the quote here? When you choose the Copperfield Vias, the price for 5 volts is 386. And if you choose the standard epoxy field, there is 48. And when you choose the untinted ones, the price is the same. So the epoxy field and Copperfield is like 8 times price difference. So 48 or 386. And I'm not sure if I want to pay so much for that. Yeah. Probably they will not continue with me. But I think we answered our question. Yeah. For that, we need to, that's exactly what I said. The tented via is not via in pad, because if you want to use via in pad, you need to fill the via with copper, not with epoxy. So yeah. Let's continue, and I will check the chat later. And I would like to really know why I'm going on mute sometimes. The new window doesn't cause it. I don't know. I don't know. It's so annoying. I would need some light, some LED to check that I'm on mute. I have to check it later. The clock, I don't know. I don't know where to route the clock signal. Never mix signals from different groups on the same layer if possible. Well, it's great tip, but yeah, no problem. Just be patient with me, because you know I can see your comments with some 1 minute or 2 minute delay. So yeah, I think I believe it's annoying, but I don't know how to. I can't solve it. It's the StreamYard. Probably some sampling period of the LinkedIn comments. I don't know. Yeah, I'm checking where to route the clock. I don't know. Ideally, I would keep the clock signal on the same layer. But it's practically impossible. Yeah, some testing job. Test run for the clocks. it's awful, but I kept the ground via here on the bottom, like facing downward, and I moved the RASN via to be facing upward, because I want to distribute the non-homogeneous, I don't know if it's a word, the discontinuity, the non-homogeneous elements in between the pair, to be in balance. So one via affects the negative clock signal, and this via affects the positive clock signal. But yeah, I don't know. Maybe I will keep this, but I don't know. It's even possible. I don't know. We'll see. What about the GLC PCB? If you select a 6-layer board, the only option we have by default is epoxy filled and untinted, and epoxy filled and cap. That's not true, because there is the copper paste filled and capped option. Yeah, ideal for via in pad and heatsink pads. So I think they are not correct. There is a six layers copper filled. I don't know. Okay. Okay. No reply. Okay. So the guide wants me to choose or establish the most difficult to route path. I know which one is that. Here. All of them. Okay, so where to start? Green ones. One of the green ones. I think I really need to go from here to here. Don't judge me now. Yeah, I'm making some tests. Yeah. How did they distribute the clock? What is the clock? What is the clock pads? These two. It means 1, 2, 3, 4. There is a gap. 5, 6, 7. 1, 2, 3, 4. Gap. 5, 7. 6, 7. What? No, I'm an idiot. 4, 5, 6. Yes, 7 here. Here. No. 1, 2, 3, 4, 5, 6, 7. Aha, probably. Yeah, probably. Yeah, they use different ports because, or even I can relocate the signals, which makes the thing like super complicated. But if you remember, like in the stream number 4 or 5, oh no, this one. Back to the DDR memory. If you remember my you probably don't. There is a tool as part of the Cube MX application, and you can relocate the signals of the wait, there are wait, I made notes from that. Let me find it. Yeah, I apologize, the note is in Czech, but you will understand the picture here. There are AC, it means address control, pin mapping, that can't be swapped. And you can see that for the DR3L, no, they use the same clock signals. Basically, no, they don't. Yeah, they do. So why I can't navigate? I can't find the clock signals here. Again, here are our clocks. 1, 2, 3, 4. There is a gap. There are 2, like a small gap, and then the clocks. 4 gap, 2 small gap. No. Where it is? Here. Clocks. Here. A4, A5. Yeah. L20, 21. Yeah, that's correct. It's correct. L20, 21. So the Gerbers. What's that? Okay. Again, 4 gap, 2. These 2 probably. Yeah, because this is not PET, it's VIA only. Okay, there is, yeah, these 2. These 2, and there is a clock, there is a VIA, and no reference plane return path vias. I don't know why. And here is a clock signal here to other vias. And okay, so we can place a via to the clock signal. So we can avoid the mess here. Because everyone is talking about rules that you must use the return path vias. You have to place the decoupling capacitors near each via when you change the reference plane, etc. Yeah, I don't know. I know we don't. Okay, if we don't change the reference plane, then we don't need the decoupling cap, or maybe we don't need the reference plane return path vias as well. Okay, that's probably the reason why they don't. Okay, that sounds like a plan. Okay, anyway. I don't know. Maybe the net allocation thing will take place soon. I don't know how to do it. I don't know. I just don't know. I absolutely don't understand how to do it. So I don't know, but probably whoa, what happens? Probably can I go in between these pads or not? Let's check it. Here, no problem, of course. And here, big problem. Can I No, I don't. No, I can't place via here. Okay. So there are like one or two, maybe one. One valley I can go in between paths, so not applicable. All must go around. But when I'm here, yeah, for instance this, but now I must connect to the highlighted path. So naturally, in the normal layout, I would switch the like reorganize these two nets. For that, I would need to place this via somewhere else. Okay, and what else? What the third signal? The same. The fourth one. I think I saved the project. I want to check if I really can switch the tracks, switch the nets. Okay, go. Okay, let me take a short break because I need a service break and this thing needs to download something. Okay, it failed. Yeah, this application is made. Here. Yeah. No, probably I don't have the project file. Okay, let's start again. What's the commercial part number? Okay, here. Ah, MP. Okay. Fan. Fan 3. This one. No. No. I was too fast. No. Yeah, start project. Okay, I was wrong. I don't know. I don't care. Yeah. I don't know. Maybe. And here there was a tool. Duties, no. Others, no. Connectivity, no. How it was called? Here. DDR categories, okay, DDR. Control Phi. Yes. DDR type 3. 16. Oh, I don't know, 4. Uh, 512 megabytes, it means 4 gigabytes, 4 gigabits, 4 gigabits. Yes. And here. I think I don't understand at all. Mapping, that's our thing. And user constraints, I don't know, and I don't see anything. So, okay. As I mentioned, there are signals that can't be relocated here. And here, the rest of them, it means all the AC signals can be relocated. And what's our issue? What's our problem? Yeah, that's a good question. What's my problem? My problem is that I can't, okay, the problem answered itself right now. I can't connect the DDR DQ data buses. It's a memory. We can connect any bit of the controller to any bit of the memory. The bits stored in the memory don't need to be in the same order as in the MPU, but I don't know if I want to do similar tricks. Yeah, they used everything as should be. Luckily, happily, yeah. Yeah, I'm checking the, no, here is the memory, yeah. Number to number, yeah. No change, no swapping. So it means that I will need to find a way, because otherwise I am doomed. Okay. Seems that this position is the only one allowed. Yeah, and from here, yeah, I can't go outside. Yeah, and what David said, a note about rotation. I don't know. Yeah, there is no rotation that when I can avoid the net crossing. Net crossings are natural, present in every single design. But the issue is that the PGA is so fine pitch that I can't route the tracks in between pads, and there are a lot of vias, etc., etc. I need to find a way. I just have to. But how? How to do that? I don't know. So, yeah, all data buses, so not applicable. This tool is fine, but not applicable here, because it can mix only the AC signals. And I'm not sure if I want to mix the addresses, the data buses. Yes. So what we can do? This. This. In this position, the blues are distributed evenly, plus minus. The reds should be routed in the gap, and the greens around the module. I don't know. But yeah, I can delete this. If I start with the first one, the issues will reveal themselves quickly. Yeah, like this. In between pads somehow. Yeah, around the thing. Yeah. And now I'm here again. The only thing is that I have to start swapping the bits in the byte. That's the only thing. They say 2 swappable bytes and swappable bits in the same byte. So they say I can swap upper and lower bytes. So lower byte is green and the upper byte is red. So we can swap them. We can swap them completely, and then we can swap bits in each byte. So we can swap the green signals in the group, and so all the bits in the same group, and then we can swap greens to blue ones, greens to red ones. So in this position, all the reds can go where the green ones are and vice versa. I go, here was the position. I still think that this position is the best. I don't know why. It's just a gut feeling. I don't know how to explain. And then I will swap the bits inside of the byte. So I will swap the bits in the red group and swap the bits in the green group. So for that, I need to know what bits are to be swapped. So let's approach all the signals closer to the module, and then I will reorganize the signals in the group. So all the green ones, but be careful, because there are not only green ones. Yeah, some of the green ones are like the strobe signals and these LDM, UDM. I don't know what the hell they mean. DQS are pairs and DQM is not a pair. So DQS are pairs. Okay, so this signal is a pair. Yeah. The pair has the different track width, yes, and different clearance, so I can't route the pairs like that. They use 0.09 for data bits and the same track width for the pairs. Okay, so I need to find better numbers for our pairs. It means I need to find the differential pair parameters with the same thickness, the same track width. Trace spacing. No, ideally manually. Unfortunately, manually. Clearance is 0.09, which is in mil. I don't know if I can use decimal numbers. Uh, 3.5 mils. Let's try. Yeah, too narrow. Yeah, I remember. Yeah. At the end we used 0.11, which is like this. Yeah. So this stack up doesn't work. This one is the same probably. I don't know why the number is red. Yeah, because it's not correct. This stack up. This stick up looked good. But the track width is still too wide. But not so much. With this stick up, it should work. Wait, it's 4-layer stick up. I need 6-layer. I have 6 layers. So what's the problem? I won't. So does it mean that just the table is incorrect? How can I get the 6-layer stick up? Here? No. Okay, so oh, see here. There was an incorrect PCB thickness. Okay, again. Unit millimeters. Trace spacing, for me, it's ideally the same as the clearance, 0.09. I'm sorry, but I need it. Yeah, too narrow. Too narrow, it's the same. Too narrow. Too narrow. But yeah, still it's too narrow here. No doubt. Uh, 7.6, but not so far. Not so far here. Okay, so if I use this spacing for the 0.0762 track width, what will be the impedance? The track will be wider, so the impedance would be higher. So let's say 110. Calculate. Of course, lower capacitance, lower because the track will be thicker, so the capacitance will be higher and impedance will be lower, of course. 7.6, so 95. 94. No, 96. Oh, go, go, go. Yes. So if I use the same numbers for the, yeah, this is our number. If I use the same number for the pair as we have the minimal numbers, it will give us 97 ohm impedance, differential pair impedance, which is within the tolerance. And this will give me the opportunity to route it. So this is the same strategy as the reference design had. The same thicknesses and the same clearance. I just need to check the stack up because it's the first one, the 3313 here. Core between 2 and 3 is, no, there is prepreg here, prepreg. It's in fact core. No, prepreg. Yeah, slightly different. Then there is 0455. No, here is 55. I'm lost. Between 3 and 4 is this one. 3 and 4. This one. Then 2 to 3, 055. Yeah. Probably I was. No, 3 and 4. 4 and 5. 55. 4 and 5. Okay, these numbers are, I'm lost. Top and L1 is this. Below is this. Yes, below is this. Below is this again. Symmetrical, yes. And below is this, symmetrical as well. No, here. Here. Okay. Oh, yeah, that's the stack up. The electrical numbers are not here. The electrical parameters constants. Okay, so now I should be able to fan out the pair. Yes, I'm destroyed today. This design is taking so much of me, but that's why I'm doing it. Oh. Yeah, the thing is that it doesn't work much because I don't know. Oh wait, there are two greens, two pairs in the greens, or not? No, the other pair is red. Okay. Okay. Okay, I have to. I have to use a different color for the pair for now, because it's not green. Greens are only data signals, data buses. Okay, it's cyan. Then let's DDR. It was LQ DQS LDQS. Greens, so far greens. DQS? No. Yeah, DQS. No. Yeah, DQS 0. DQS 0. Regarding the colors. Yeah, there is no color. No, yeah, here is the color. CB color. But yeah, it overrides. Okay, okay. The net class was overridden with this, probably. But if I choose clear color, it should be stale blue, not DQS. Yes. Yes. Okay. Still didn't help much. So I need to I don't know. This didn't help because I can't see the connections. Okay, now I need to assign so if I go like this and here, I need to assign the most bottom and most left signal. It means DQ4. So this one, DQ5, should be DQ4. So now I can connect the first green signal like this. Now this one, DQ4. I need to assign like DQ6. So DQ4 must be DQ6. So we have to swap this one, these ones. Okay, so yeah. This routing is not finished. It's like to see the distances and to change the order. So nothing really important is happening here. Now I need to assign this signal to DQ0, but yeah, but ideally now I would DQ2 here. DQS, how did they route it? It's here, like third row and 5, 6. Third row, 5th and 6th. Here. Here. Yeah. Yeah. They went in between paths. Okay. It's perfectly applicable to me here. Okay, so there will be a pair of vias. DQ2. So DQ6 is DQ2. Yeah, this is the pair. That's the pair. No, it's not. Not yet. DQ0. So DQ7 is DQ0. Here. Now the pair. So I'm going to approach the spot. Yeah, that's always. Okay, we have to swap them. Luckily, it was possible. Something like this. Now. There is no green signal in here, so we have to start from top here. So this can DQM. DQM is the like, I don't know, data wallet or something. Okay, now here. Yeah, can be this one. Of course, I'm going short of space, but I think I will get there. Yeah. Something like this, I will correct it later. And DDQ, 2 to 3. 2, okay. 3 and 2. Yes. This is awful, I have to correct it right away. Something like this. Now, where are you? Here, last 2 of the greens. Here, and the last one. Here, okay. So with the pin swapping, it's it's possible to connect it. So next week I will continue in this regard with the bit swapping inside of a byte with the green one, with the red ones, like the same horseshoe shape, and then I will calculate the longest track, or to identify the most difficult to route track, and then to delete all of them and start over with the target track length parameter set. I'm sorry for the confusing stream today. As you can see, I am learning on the go. Last but not least, if you want to support me, please consider there are 2 courses, as always, on Fedival, KiCad for beginners and KiCad for makers. You will learn a lot, and I promise you there are no DDR routing in there, so I really knew what I have done in this course when I was recording this course. So fedival.com, 2 courses, special promotion will get your PCB assembly for free if you enroll the course, for both the big one and the small one. You will receive a coupon and you will redeem it at nextpcb.com for free. So thank you for watching, thank you for being with me, thank you for everything. I know that it doesn't go as smoothly as I want to, but as you can see, the board is not a big deal. There are like a few signals, but the DDR memory is the game changer here. And I think we slowly approaching the target. We are not still there. There will be a long way. As you can see here, we have to allocate some space for the vias, for the clocks. There are a lot of things to do, but we are slowly going there. Thank you for being here, thank you for watching, and see you next week. Bye.